Okay, so this lesson is on continuity, and I am going to start talking about it right now. Maybe I should have started at the beginning when I did this, but whatever. Okay, basically, if a function is continuous, we talk about it being continuous on its domain. So sometimes the function 1 over x is called continuous, even though, let's see, it goes like this, right? Even though it's obviously discontinuous here because there's a vertical asymptote, but it's continuous on its domain. So when x is not equal to 0, um, it's continuous on its domain. That was just a little sidebar. Don't stress about that. Basically, a function is continuous if you don't have to pick up your pencil to draw it. So determine if f of x is continuous at x equals -2. Well, we can look at the graph and clearly see that it is discontinuous at -2 because we would have to pick up our pencil to keep drawing. At 0, however, it is continuous because we wouldn't have to pick up our pencil. And at 3, it is not continuous because we have to pick up our pencil to put the dot down here. Now, there are 3, this is the most important thing that you've learned so far this year, right now, coming up right here. Anytime a question on a test or an AP test or anything says, prove whether or not it's continuous, the first thing you have to do is show that f of the number exists. So let's go back to this question here. Does f of 2, now we're talking about -2, I mean, does f of -2 exist? Well, it does. F of -2 is 2. That was step 1. Step 2, show that the limit as x approaches 2 exists. Well, let's go back and look. The limit, so you'd have to show that the limit as x approaches 2 from the left is 2. The limit as x approaches 2 from the right is -1. Therefore, the limit as x approaches 2 does not exist. Therefore, f of x is not continuous. As soon as you get to one of these 3 things being disproven, it is not a continuous function. Let's try the next one. We wanted to know if it was continuous at x equals 0. We can see that it is, but what is f of 0? Well, it is 1. What is the limit as x approaches 0 from the left? Well, it's 1. What is the limit as x approaches 0 from the right? Also 1. Therefore, the limit as x approaches 0 equals 1. So far, so good. The third condition is that these 2 things have to have the same value. And since they are both 1, it is continuous. The function, don't ever say is. The function is continuous at x equals 0. Now, finally, we want to know if it's continuous at x equals 3. So, we would say f of 3 is, well, it exists, and it is -1, right? Because that's where the point is. But you can clearly see the limit as x approaches 3 from the left and from the right is 0. So the limit as x approaches 3 is 0. And since these 2 are not the same, it is not continuous. Please remember that to prove continuity, you must show these 3 things. Let's try some. Determine whether it's continuous. So the first thing we have to do is find f of -1 and make sure it exists. Well, -1 squared is 1 plus 1 is 2. The next thing we have to find is the limit as x approaches -1. Well, this is this doesn't have any asymptotes, and it's defined for -1, so we can just plug in -1, and we get 2. And since the limit as x approaches -1 equals f of -1, it is continuous. Okay, the next one, f of -2 equals, Negative 2 squared is 4. 4 plus 4 is 8. The limit as x approaches negative 2. Well, we can just use direct substitution here because it is defined at negative 2. Whoa, 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 whoa. So again, I would just plug it in, and it would be negative 2. Oh, sorry, f of negative 2 is not 8. My fault, my fault. The denominator is 8, but the numerator is negative 2. So it's negative 2 over 8, which is negative 1/4. And what am I trying to say here? The limit as x approaches negative 2 is also negative 1/4. Therefore, it is continuous at x equals negative 2. Now let's look. X over x squared plus 4. Let's just confirm on the calculator. Why do you hate me? Why do you hate me? Maybe I should do this. Desktop annotate. Oh no, I wanted this. Clear. Come on now. Y equals clear, clear, clear. Okay, calculator hates me. So we're just going to move on. No. Okay, well, so much for that plan. We can look at a graph by making a table of values, maybe. We know that it has an asymptote at y equals 0. And we know that when x is negative 1, this is negative 1 over 5, so it's negative 1/5. When x is negative 2, it's negative 1/4. And when x is 0, it's 0. When x is 1, what are we? 1/5. When x is 2, 1/4. So it's probably like this, which is the opposite of 1 over x. Does that make sense? Kind of. Okay, so you can see that at negative 2 it is continuous. It's not continuous everywhere, but it's continuous at negative 2. Oh, but it goes through 0, so there's not an asymptote at x equals 0. This is interesting. I really wish I could look at it. Oh, I can look at it on a calculator and then draw it. How about that? Clear. X divided by x squared plus 4. Oh, it's an interesting graph. Basically, it looks like this. Ah, cool. And then it comes back down and it's asymptotic here and here. Anyway, I just wasted a whole bunch of time for no reason. Okay, finally. Most of the time when you're asked to prove something's continuous or not, it is with a piecewise function. So let's look at this piecewise function. First we have to check, oh, I didn't give you a c value, which I know I did. Nope, I guess I didn't. The c value for this is, must be 2. It must be 2. Yeah, c equals 2. So the first thing we have to find is f of 2. Well, f of 2 I would evaluate in the top because it's when it's equal to 2. 2 times 2 is 4 plus 5 is 9. The limit as x approaches 2 from the left is all, I'm going to evaluate up here, so that's 9. The limit as x approaches 2 from the right, I'm going to evaluate in the bottom because this is where numbers are bigger than 2. That's also 9. So yes, this function is continuous because f of 2 equals the limit as x approaches 2. Okay, next slide. There is a theorem we have to talk about, and it's called the intermediate value theorem. And I'm hoping I can just click on this link, but of course that doesn't work. How do I copy it all? Like that. edit, copy, Control V if I can find my keyboard. Is this fun for you listening to this? Okay, this is the intermediate value theorem. Now, in a math book, it's very mumbo-jumbo-y, but I like the way this describes it. If you have 2 points connected by a continuous curve, so that's rule number 1, it has to be continuous. And if you have 1 point below the line and another point above the line, then somewhere in between those 2 points, it must cross the line. That only makes sense because it is continuous. So this is the math mumbo-jumbo. If the curve is continuous, from A to B inclusive, then there must be a y value in between these two y values, and there must be an x value that coordinates with that y value. That's all we're saying. Keep in mind, these are y values. F of A and F of B are y values. It could happen more than once, that there's more than one time that it crosses that line between A and B, but it has to happen at least once. Why is it useful? Or how is it useful? If you can show that there's a point above a line and a point below a line and that the curve is continuous, then you can say that somewhere in between there is a value where it crosses that line. And most of the time it comes in this form. Is there a solution to this function between 0 and 2? So the first thing you would do is evaluate the two endpoints. So plug in 0 and you get -2. Then plug in 2 and you get 14. Since it goes from being negative to positive and it's continuous, there must be a 0 somewhere in between. So that's the intermediate value theorem. It's going to show up a lot more. And I just went the wrong way. And now someone's coming in my office and they're going to hear me make a video and it's kind of funny. Okay, finally. This is an actual free response AP question. So the first thing we have to do is determine if f is continuous at x equals 3. So first we evaluate f of 3, and it is 2, because we have to put it in the top function because that's where 3 is defined. Then we evaluate the limit as x approaches 3 from the left, which is also 2 because it's the top function. Then we evaluate the limit as x approaches 3 from the right, which is the bottom function, which is also 2. So for part A, we can say f is continuous because f of 3 exists and f of 3 equals the limit as x approaches 3. Find the average value of f of x on the closed interval from 0 to 5. So that's where we would find the slope. Remember, average value means slope. So we would plug in 0. We would do f of 0. Sorry, we would do f of 5 minus f of 0 all over 5. So what is f of 5? Well, we can evaluate that down here. That's 0. What is f of 0? Plug in 0, you get 1 all over 5. So the average value is -1/5. The last part's hard, and these are the ones that show up a lot. Suppose g is defined by that piecewise function, where k and m are constants. If g is differentiable at x equals 3. Now, what we haven't talked about is anything with derivatives yet, but differentiability implies continuity. So if it is, this is important, write this down somewhere. If a function is differentiable, that word, then it must be continuous. If a function is continuous, it doesn't necessarily have to be differentiable, and we'll talk about that once we talk about derivatives. But the whole reason, the AP test will never give you more information than you need. So you need this term, this phrase, to tell you that it's continuous at x equals 3. So we know that f of 3 must equal the limit as x approaches 3 in order for it to be continuous. What is f of 3? Well, f of 3 is 2 times k. Now let's see where I got that from. When you plug 3 in for x, you get 4. Square root of 4 is 2, so we get 2k. The limit as x approaches 3 from the left is 2k, but from the right, It is 3m plus 2, but that has to equal 2k. Now let's see where I just figured all that out from. The limit from the left at 3, when I plug in 3 for x, gives me 2k. In the bottom function, when I approach 3 from the right and I plug in 3 for x, I get 3m plus 2. In order for this function to be continuous, these two things must be equal. So, what is the value of k and m? What are the values of k and m? What else do I know it has to equal? Okay, so we got this far. This is all you can do up until now. We're going to have to start talking about derivatives of this because the derivatives have to be equal as well. But as long as you understand that 3m plus 2 must equal 2k, then you understand continuity, and we have done our job for this section.